All right, let's talk about this, but don't write it down, especially this slide right here. The integral of f of x from a to b is basically saying what's the area under the curve from a to b. So we're really looking for this. Well, we've learned that the best way to do this is to find the area of rectangles. And we're going to do that an infinite number of times. So basically, we're letting the limit as n approach infinity. We're going to sum, this is what this symbol means, we're going to sum up rectangles. How many of them? Well, 1 to infinity of them. And then we basically have the height, and then we're talking about the width. Very, very confusing way of saying this notation represents adding up an infinite number of rectangles. And that's going to be equal to the integral of that f of x. If you have no idea what I just said, that's okay. This is a little bit less nasty, and I'd pause this video and get this down. So the takeaways here is that this is going to be the function that you're going to integrate. This is the variable of integration, so these two should match. This would be your lower limit, and then this would be your upper limit. And this is the integral sign. And I mentioned this in one of the classes, but kind of interesting that this looks like the letter S, and we are summing up an infinite number of rectangles. So that's why it looks the way it does. We're basically summing up an infinite number of rectangles. What is the dx thing? Well, if you want, you're welcome to read all this stuff right here. But the practical explanation is all we really care about, this idea that it identifies the variable. That's actually not the reason why it's there, but it's the practical reason. If you want to read the more complicated explanation, it's basically an infinitesimally small width of a rectangle. But let's not get caught up on that. How about this? What does this mean? Well, this represents the area under the curve. Well, this is our curve right here. And this is our lower bound, which would be a -2, and our upper bound, which would be 2. So if I actually asked you to calculate this, you could, because you know that this is a semicircle, and the area of a semicircle is pi r squared over 2. Here our radius is clearly 2, so we'd have pi 2 squared over 2. Or 4 pi over 2, which is a 2 pi. So the answer to this problem would be a 2 pi. So this question is asking, what's the area under the curve for this function, with x being my variable, from -2 to 2? Well, just find the area of that semicircle. More generally, what is an integral? Well, it's simply the area under a curve if we're thinking about a definite integral. Okay, we're talking about the area from A being right here, and B, my upper bound, being right there. F of x is my function that I'm graphing, and the answer to this would be the area of the blue. You're certainly welcome to read this, but I'm not sure it's going to add too much to your understanding. Just know that the integral is finding the area under a curve. Area is always positive, right? If I asked you, what's the area of this gray shaded region, you actually would have, the integral would actually be negative, so you would have to negate your negative to get a positive. So in other words, if I ask you to find the area of something, you need to answer with a positive number. However, integrals can be negative because it would represent this right here would end up being negative. This here would represent it as positive, and this would be positive. So an integral ends up being the area above the x-axis minus the area below the x-axis. All right, to end up this video, we're actually going to do a definite integral. And I want to remind you that a definite integral has lower bounds and upper bounds. Okay, so you can think about the graph 4 plus cosine x. Let me just quickly graph it in Desmos. And when you're doing this problem, folks, make sure that you have your calculator in radians. So what I'm really asking is, this is going to start at 5, believe it or not, and it's going to go down, and then it's go up. Okay, wherever 2 pi is, I'm not completely sure. I'm thinking it's probably about here. I'm asking you, what is the area under the curve? So let's do this. First thing we're going to do is do an LRAM, and then we're going to actually calculate it with our calculator. So you're going to have to watch another video. Please do watch it. It's going to be like 30 seconds. All right, so using LRAM, I'm going to have, what are my things going to be here? Okay, well, think about that. This is going to be a pi over 2 right here. No, actually, it's going to be a pi. Silly me. Whoop. I should have made this bigger, eh? This one here is going to be a pi over 2. And this here is going to be 3 pi over 2. So you can see here I've got a jump of half pi's. So this is going to be a jump of 1/2 pi, another 1/2 pi, another 1/2, another 1/2. So for the LRAM, I'm going to be choosing the following. This one, this one, this one, and this one. So I'm going to have, what's my width of my rectangles? Always a pi over 2. Okay, and then I'm going to have, we'll say f of 0 plus pi over 2, f of pi over 2 plus pi over 2 times f of pi plus pi over 2 times f of 3 pi over 2. So I'm going to be plugging this 0 in, and I can do this one pretty easily. Cosine of 0 is 1. So I'm going to have a 1 plus a 4, because cosine of 0 gives me 1. So this is going to be pi over 2, which I'm going to pull out because pi over 2 happens in all of these. So this is going to give me a 5 plus, okay, what is cosine of pi over 2? Okay, well, cosine of pi over 2 is going to give me 0. And let's just check that. Let's remember what my cosine graph looks like. Okay, it looks like that. Let me go ahead and label. This is my 0, this is my pi, this is my 2 pi, this is my pi over 2, this is my 3 pi over 2. I don't think I'll need more than that. All right, so going back to plugging in, I know you guys get freaked out with trig, but plugging in pi over 2 here, I got cosine of pi over 2 is 0. See how it's on the x-axis? So I get 4 plus 0. It's 4. Okay, now what's cosine of pi? Cosine of pi is a -1. So we'll have 4 plus -1, which is going to give me a 3. Okay, and then last but not least, 3 pi over 2. Again, we get a 0, so it's going to be 4 plus 0. And that's going to give me that. So it's going to give me pi over 2 times, well, 5 plus 4 is 9, 10, 11, 12, 13, 14, 15, 16. Okay, that's going to give me 16 pi over 2. Now, it's definitely worth actually finding this answer because we're going to check it on the calculator. And one of the classes I've actually taught you how to do this, so if you want to go ahead and check your answer, you can. I think the other class we did not get to this. So I got 25.1327, but the actual answer we're going to write as 0 to 2 pi of 4 plus cosine x dx. Okay, maybe you can follow me audioly, I don't know. Press math, and then you're going to scroll over and scroll down to 9. You're going to put your 0 down below, then the 2 pi up above. You're going to type in 4 plus cosine x, absolutely making sure that you have your calculator in radians. And the actual answer is 25.1327413. So like really, really close, if not exact, on this actual answer. So please watch this video showing you how to do this in your graphing calculator. You press math and then 9 and then you plug in. Thanks for watching.